Hello everyone, my name is George Patel and this is the video presentation for the assignment 2 of Applied Data Science. And in this assignment, we're going to be working with Iris dataset. In the first in the first line, I'm storing the path of the Iris dataset file in the variable named file name. So this is the location where it's stored on my hard drive. In this line, I'm trying to read the content of the Iris dataset and I'm storing it in Iris variable name. Now, in order for me to do that, I need Pandas library. So I'm importing Pandas as PD and I'm using pd.read_csv function to read the content of that CSV file and storing it in the variable iris. Now, just to make sure that we got the correct data, I'm printing the first 5 rows of the iris dataset with the command iris.head. Now, as you can see, the last column contains strings. I'm going to convert these strings into labels. 0 for setosa, 1 for versicolor, and 2 for virginica. Now, I'm going to convert the strings into integers by using this type command. Type method is used to cast a pandas object to a specific data type. Type function also provides the capability to convert any suitable existing column to categorical type, which is what we're doing in this case. Now, this command iris.spaces.cat codes Cat codes basically is a process of factorization, meaning that each unique value in that category will be given an incremented integer value starting from 0. So in our case, it will be 0, 1, and 2 since we have 3 strings in that column. So I'm going to use those cat codes and store that in the last column of iris, which will replace the strings. And just to make sure that we got the correct output, I'm going to print the first 5 rows of the iris dataset again, and as you can see, the species column, it has been replaced by the numbers. So in this case, the first 5 examples were of setosa, so now we have 0 instead of setosa. Now in the next command, I'm selecting the first 4 columns of the data frame and I'm storing it in the variable x. So for that, I'm going to drop the last column, which is named species, and I'm storing the rest of the columns in x. In the next command, I'm storing the last column and calling it y. So I'm just storing iris species column in y variable. Now moving forward, it's time for us to split our dataset into training and testing data frames. Now, in order for me to do that, I'm going to import train_test_split from sklearn.module_selection, and I'm going to split my data set into X and Y with the test size of 20% and random state as 113. And just to make sure we're on the right track, I'm going to print the first 5 rows of each data sets. So this 2 data sets are inputs and these 2 are the labels. The length of the x_train is 120, and which is our training data set, and this is our testing data set with the length of 30. Now in the next step, I'm calculating the result, like how accurate my model works on unseen data. So we are going to use our testing data frame for that, and I'm calculating the loss and accuracy for that, which is 100% accuracy because I tried like 2 to 3 times before this attempt, which made it pretty accurate. But if I try it again, it probably won't be the same, as you can see. Now moving forward, I'm going to convert ytrain and ytest into categorical, and I'm going to call them one hot train labels and one hot test labels respectively. And in order to do that, I'm going to import to_categorical function from TensorFlow.keras.utils. And as you can see, I'm converting both ytrain and ytest using that to_categorical function, and I'm storing it in the variables one hot train labels and one hot test labels. Now moving forward, I'm defining my sequential model, which contains 3 dense layers. And for that, I'm making a few imports. In my model, I have 3 layers. For the first and second layer, I'm using 100 neurons and ReLU activation function. For the last layer, we're going to use 3 as the number of output. The reason being that for the output labels, we have 3 options, 0, 1, and 2, as mentioned in the categories part above. Now in the next command, I'm compiling my model using optimizer RMS prop and the loss function as a sparse categorical cross entropy, which is the most appropriate option for the categorical dataset that we have. And by the way, we are using softmax activation for the network because as again, we have a categorical dataset, and these two are the most appropriate options for those datasets. Now I'm fitting my model using 20 epochs and batch size as 10. And the accuracy that I got at the end was 94% and the loss of 0.014, which is pretty good. Now moving forward, in line number 43, I'm calculating the result to see how accurate my model works. And for that, I'm going to use network.evaluate function to get the loss and accuracy based on the new unseen data. And for that, we're going to use our testing data sets. And and the attempt that I made during this time, I got the accuracy of 96% and loss of 0.13, which is not bad considering that we have unseen data. Now for the next command, I'm making a few changes to the network. I'm using 10 neurons for the first 2 layers, and the third layer remains the same. And I'm using the same parameters for the compiler as well. And after I fit my network, I get the accuracy of 70% at the end, which is affected in major terms because of the epoch number and also the number of number of units, number of neurons in the first 2 layers. Now, if I calculate the loss and accuracy using the network.evaluate for the unseen data based on that network, I get 53% accuracy, which is pretty low. So what I think is the number of neurons in the network layers and also the epoch size has a major impact on the accuracy of our network. Speaking in simple terms, adding more layers will improve the accuracy of the model, and it will also reduce the overfitting because we're basically adding more data to the model using those extra layers, and it gives less chance for our model to overfit based on the new samples. Now, for this command, I tried making a few changes. I tried manipulating some of the epoch numbers and the number of units in the first 2 layers, and I was getting huge difference on accuracy. So that makes me believe that regardless of the loss function or optimizer, I think the number of layers and epoch number has major impact on how our model gives accuracy. So based on the result that I got, we should try to find the ideal epoch number and the number of layers for our network which works with it. So that's all for the video presentation of this assignment. Thanks for watching.